Welcome to lesson number 1, module 3 of the Big Data and Hadoop Developer course. So in this particular lesson, we will be introducing the concept of the Hadoop distributed file system. So in the previous module, we learned how to install the Hadoop ecosystem tools such as Pig, Hive, HBase, Coop, Flume, Uzi, and also we went through a step-by-step installation of the Hadoop distribution itself. So in this particular lesson, we'll be understanding the Hadoop distributed file system. We'll explore the core components of HDFS such as NameNode, DataNode, and secondary NameNode, and we will have a look at the architecture as well. If you remember the lesson where we introduced Hadoop, we know that Hadoop has two major components. One is the HDFS and the other one is the MapReduce. Now, HDFS plus MapReduce gives you Hadoop. So like we discussed before, Hadoop offers you two solutions, a solution to store your data and another solution to process your data. Now, the storage part of Hadoop is handled by HDFS. Now, HDFS, or to be precise, the Hadoop distributed file system, is a Java-based file system and it is responsible for all storage activities inside Hadoop. So think about this file system very similar to any other file system that you know. For example, if you are working on a Windows platform, you will have file systems such as NTFS, and in the Linux platform we have file systems such as extended type 2. So just the similar way, we have a specifically designed file system for Hadoop which is called HDFS. However, HDFS is quite different from the traditional file system in a way that this is designed to leverage the distributed power of computing. In other words, the other file systems such as NTFS and FAT usually works on a single machine, wherein HDFS works in a cluster. Now let's explore this concept further in the upcoming slides. Now, if we look at the HDFS from an architectural point of view, we understand that the entire storage happens in a master-slave architecture. Now, in Hadoop, whether it is storage or processing, it is all handled by a master-slave architecture. So that means we need to have one or more machines in the master side and one or more machines in the slave side. Now, if you just have some machines in a Hadoop cluster, it is difficult to differentiate which machine takes up the role of master and which machine takes up the role of a slave. So to give that particular role to a machine, we have to have certain daemons or services running on a machine. So just like you see on the picture, on the master side of the HDFS, we have two main components called the NameNode and the secondary NameNode. Now, they are completely different. The NameNode and secondary NameNode are different, and both of them are master daemons. Now that means you can install Hadoop on a machine and bring up this particular service or a daemon called NameNode on that, and that machine will become a master. And you can have another machine where Hadoop is installed, and if you bring up the daemon or service called the secondary NameNode, that will become another master. Now, in relatively smaller clusters, you can have both these daemons on a single machine. So I can have a single server which is acting as my NameNode as well as the secondary NameNode. Now, the key point you need to remember here is the master machines do not offer any storage. They are there to manage, not to store anything. Now on the slave side, we have a daemon called the DataNode. So If you think about a Hadoop cluster where imagine you have close to 100 machines, one machine typically will be the name node or the master and 99 will be the data node. So data node is the slave daemon or the slave process in terms of HDFS. Now let's go further and understand the roles of each of these daemons. Now, if you look at the name node, it is a single instance. In the sense, in any production cluster, typically you will have only one active name node. So it is a single instance. Now, this runs in the master node, and the role of your name node is to manage the file metadata. Think about the name node like this. The name node is always connected with all the data nodes in a cluster. Now, as we understand, the data nodes offer storage, right? So if you want to store some data to a Hadoop cluster, you talk to the name node first because name node is the master. Now, name node will contact the data nodes and will come back to you saying that, hey, you know what? You can store the data in data node 3, 7 and 9 because they have very less space utilized on them. So name node manages the entire storage space. And when you store a file in a Hadoop cluster, the file gets spread across the cluster. For instance, if you have a very large file to be stored in a Hadoop cluster, the file usually gets divided into something called blocks and spread across multiple data nodes. So that means if I store a file, I need the service of someone who should know the location of these individual chunks. And that is exactly what a name node does. The name node remembers the location of each and every file in a Hadoop cluster so that when you want to read the file, you can contact the name node and say that, hey, I'm looking for this particular file. Do you mind sharing me the information as to where I can find it? Now the name node is going to look at its metadata, which is basically the location of the files, and going to say that, oh well, I do know where it is. It is actually split into 4 and each piece is on this data node. You collate all these pieces, you have your file back. So the name node acts more or less like an indexing machine which remembers the location and communicate. Whereas the data node runs on all the slave nodes, and the idea behind a data node daemon is to offer the raw storage for HDFS. So usually the data node machines periodically report to the name node. Usually every 3 seconds they send a heartbeat signal to the name node just to let the name node know that they are alive. And also very frequently they send something called block scanner report, which will tell the name node how many blocks the particular data node has and how much storage space it has and how much space is free. So this continuous communication between the name node and the data nodes gives a complete picture about the storage of the cluster to the name node. So that is why we need a name node to contact the individual data nodes inside a Hadoop cluster. Now you also have another daemon called the secondary name node. Now the secondary name node does kind of a housekeeping service inside a Hadoop cluster. What it does is it will connect your primary name node every 1 hour. Now that's completely configurable by default every 1 hour, and then copies the metadata to itself. So you can see that the secondary name node backs up the metadata every 1 hour from the primary name node. However, don't be deceived by the name secondary name node. If the primary name node goes down, the secondary name node will not take over. Please make a note of this point. The secondary name node is not a hot standby machine. It is not a replacement machine also. It is just doing a housekeeping service. And as we will see in the later lessons, there is another service which will allow the automatic takeover in case the primary name node So what are the common attributes of the Hadoop distributed file system? Well, HDFS usually works very well on large files. So we understand that big data means it is huge amount of data. So if we are giving small amount of data, or in other words small file sizes, then that is not going to have a good performance on HDFS. Ideally HDFS works very well on large files. Now the files stored inside HDFS are write once read many. Now this is the most important point. This means once you store a large file inside HDFS, imagine you're storing a file having a size of 1 terabyte, you cannot update anything inside the file. Either you can delete the file or you can append to the existing file. The updation process is not allowed inside HDFS. And HDFS is designed for processing entire file, not for random reads. So usually whenever you want to process a file, the entire file is read. You cannot process a part of the file. And hence HDFS is more suitable for online analytical processing kind of scenario.